So, Mr. Rudra, the velocity of a freely falling body is a function of distance and acceleration due to gravity g. Show that by method of dimension v is equal to k root gh. So this is similar question like we have done in question number 3. So velocity is a function of, so there would be some constant which I am not aware of, some constant, some number. It can be half, it can be 2, it can be 3, I don't know, but it is there. And this is one of the limitation of dimension analysis. So this velocity is a function of distance through which it falls. So this distance would be given by m0 l1 t0. Mr. Rudra, any doubt? So m0 l1 t0 raised to power some power a which currently I'm not aware of, and acceleration due to gravity. So acceleration due to gravity is m l t, again raised to power something which I am not aware of, and acceleration due to gravity is a meter per second square. Meter per second square. So this would be 0, 1, minus 2. This is one thing I need out. So velocity would be given by again some mlt. So velocity is a meter per second. Velocity is meter per second. So this would be 1. This would be minus 1. This would be minus 1. And the mass would be equal to 0. That is it. So, if you have done this step right, then, at almost 60% or 70% of the question is over if you have done this right. So because now all that you need to compare is the masses, length, and the time. So if I compare masses, 0 is equal to 0 plus 0. So I get nothing out of the mass equation. So I'll have to try the length equation. So length equation would be 1 would be equal to A plus B, and the time equation would be equal to minus 1 is equal to, this is 0, this is minus 2b. So from third equation, what I get is that my b is half. And from second equation that I get is that my a is also half. Mr. Rudra, any doubt? So my equation would look something like v is equal to k. This quantity raised to power a. So this quantity was height. So height is raised to power half. This quantity is acceleration due to gravity. Acceleration gravity raised to power half. So in terms of formula, this can be written as v is equal to k h a. Any doubt? Yeah. So let us try to do another simple question. Using the method of dimensions, derive an expression for energy of a body. So energy of a body executing SHM, assuming the energy depends upon the mass. So some constant, mass raised to power a, frequency raised to power b, and amplitude of vibration r raised to power c. So this is how I can write the expression. Now let me analyze the energy part a bit. So I know that energy is equal to work. Work is equal to force into distance. Force is equal to mass, acceleration, distance. So in terms of MLT, mass is kg, acceleration is meter per second square, and distance is meter. Therefore, energy in terms of MLT can be written as 1 to minus 2. Mr. Vantika, are we clear? So this is how I find it to be the simplest. If I know the formula, I know the units, and then I convert those units into in terms of MLT. This is the easiest way I know how to solve these questions. So my MLT would be equal to K. This is my mass. So this would be M LT. This would be 0, this would be 0 whole power A into, this is frequency. Now, see, for frequency, I know that the unit, the SI unit is hertz, and it is always cycles per second, number of cycles per second. So cycles won't have any unit. So the unit would be per second. So hertz is equal to per second. For ICSA class 8th, 9th, 10th, we have sound, we have waves. These two chapters keep coming in 3 classes. So if you remember, so frequency would be M L T raised to power minus 1, and there is a B outside. Are we clear? So what I consider is that these kind of questions are a fair game, because you have, in class 8, 9, 10th, you have seen these quantities at least. Now, if you are not aware, then it is your mistake. But, if I put something like maybe a Planck's constant or coefficient of viscosity, so that is a bit difficult. But these are fair game. So this R is distance. So M L T C. Are we clear? And now I will have 3 equations depending upon MLT. So first equation when I use mass would be 1 is equal to, CB check karna, A, that is it. Because this would be 0, this would be 0, and this A into 1. So my A is 1. Are we clear? Now let me make an equation out of the length. So length 2 is equal to, see, this is 0, this is 0, and this is C. So my C is equal to 2. Are we clear? Mr. Rudra, समझ आ रहा है नहीं आ रहा?
Yes.
And my third equation would be for time. That would be minus 2 is equal to 0 minus B and 0. So B is equal to 2. So my formula would be energy is equal to some constant into mass frequency raised to power 2 and radius raised to power 2. So this should be my final expression. Are we clear? And just to be sure, I can, check the final format for units. I am clear that my energy on the left hand side has a unit of kg meter square upon second square. So if I multiply my right hand side, again it should be kg meter per second square. So let me check for whether this is correct or not. So this is mass. So this is kg. This is 1 upon second square. This is meter square. So kg meter square upon second square, kg meter upon second square. So my work is correct. Any doubt? Great.